Hi, and welcome to lesson 17.1, which is all about, you guessed it, representing linear non-proportional relationships. Whew, boy, that's a lot of big words here. We're going to try to make sense of all of that. And we're going to be using tables, graphs, and equations to represent these situations. And we're going to begin with an equation here. And our first equation comes from example 1. And it says here, this equation, boom, I already circled it, gives the total charge for one person, Y, renting a pair of shoes at a bowling X games at Baxter Bowling Lanes. So here's their ad right here, and it's $3 per game, $2 for the shoe rental. And we're going to make a table of the values for the situation. We have to first choose several values for X that makes sense in the context. So, well, what makes sense? Bowling anywhere from 1 to 4 games makes sense. So there's our X, and then we're going to calculate the cost for bowling those games, each of the games in dollars here. And we're going to use this equation that was given up here to calculate that. So one game, 3 times 1. 3 times 1 is 3, plus 2 is 5. If I plug 2 in for X instead of 1, we will get, what, 6 plus 2 is 8. So there's 8. And then 3. 3 times 3 is 9, plus 2 is 11. And 4. 4 times 3 is 12, plus 2 is 14. So there is our table of values, and we use that over here. Okay, so it's your turn. And Francisco makes $12 an hour doing part-time work on Saturdays. He spends $4 on transportation to and from work. And this equation, y equals 12x minus 4, gives us earnings, which is y, after transportation costs for working x hours. Make a table of values for this situation. So we need to figure out, well, what values would make sense right here. And I'm going to go with, how about 2? So I'm going to go with 2 hours. Let's go 2 hours, 3 hours, 4 hours, and 5 hours. So if I use 2 hours, now I'm going to use this equation right here, y equals, so I'm going to put it over here, y equals 12 times x minus 4. And x is going to be 2. See, that's what I got going right here. X is going to be 2, and then x is going to be 3, and 4, and 5 in our equation. So I have 12 times 2 minus 4. And 12 times 2 is 24 minus 4. Well, that's 20. Okay, so y is 20. So if he works 2 hours, he's going to earn 20 bucks. 3. So y is equal to 12 times 3 minus 4. So that's 36 minus 4, which is what, 32. Okay, so that's going to be 32. And then y equals 12 times 4 minus 4. What, that's going to be 48 minus 4, which is 44 bucks. Okay, and then the last one, 5. So y is 12 times 5 minus 4. That's going to be, what, 12 times 5 is 60 minus 4, and that's going to be 56 bucks. And there's our table from our equation. There you go. So examining linear relationships, and we can recall that a proportional relationship is a relationship between two quantities. Okay, let me just put this into regular words. At least this is how I see it. When we see 2/3 equals 4/6, that's a proportion. It's two equal fractions. And so this is a proportional relationship. Now the graph of a proportional relationship, it says here, it's a straight line through the origin. And when ratios between quantities are not constant, a relationship may be linear but not proportional. And so we have this example where the entrance fee for a Mountain World theme park is 20 bucks. Visitors purchase additional $2 tickets for rides, games, and food. And here's the equation that gives us the total cost Y to visit the park, including purchasing X tickets. And so we have a table, and here are, just like we had before, some sensible values. You might buy 0, 2, 4, 6, or 8 tickets, and so on. And this is the price that you would pay for those tickets. And I want to show you how we end up with those values. We have this y equals 2 times x, and x in the first case would be 0 plus 20. And so that'd be 0 plus 20, and that is just 20. And so that's how we end up with this value of 20 right here. Purchasing 0 tickets, 20 bucks. Now if we buy 2 tickets, and let's think, 2 times 2, that's 4. 4 plus 20, well, that's 24. So we would spend 24 bucks. And if we have 2 times 4, 2 times 4 is 8 plus 20, that's $28. So we place $28 there. And then 6, 2 times 6 is 12, 12 plus 20, that's 32. And so that would be $32. And then finally, 8 tickets, 2 times 8 is 16, plus 20, that's 36. And so we have 36 bucks there. So we have these order pairs. Say the order pair is the x number, the x number and the y number. We can graph these. This together makes a point right here, and this makes a separate point. Each of these are going to make separate points on our graph here. So we're going to plot them, and we're going to describe the graph. So let's move this over here, and our first order pair is 020, sorry. So 020 is, I'm going to make this bigger here. So 020 is right there. And then we have the next one of 4 and 28. Oops, I brought that up. So it's going to be 4 and 28. So no, I'm sorry, 2 and 24, and then 4 and 28. So 2 and 24 is here, and then 4 and 28 is going to be right here. And then we have, what do we have? We have 6 and 32. So 6 and 32, and then 8 and 36, 8 and 36. And here it is. So describe the shape of the graph. Well, it looks like we have a line right there. So the shape, oops, move this over. The shape is a line. The shape is a line. So linear, okay, is a straight line. And then right here, find the rate of change between each point and the next. Is the rate constant? So what I could do is, well, what is the rate of change? What we're looking at is from here to here. What's the rate of change, the rise and the run? Well, how far did it go up? It went up, that went up 4 and over 2. In each case, it went up 4. Remember, vertically, this is a change of 4, and horizontally, this is a change in 2. See, it goes from 2 to 4, and it goes from, what, 20 to 24, yeah, so, and then 24 to 28, and 28 to 32, and 32 to 36. So that's going up 4 and over 2. So the rate of change is 4 over 2, which equals 2. So there's the rate of change, which is the slope, by the way. And is the rate of change constant? Yes. The rate is constant. Okay. Next, calculate the rates of change for the values in the table and explain why the relationship between the number of tickets and the total cost is not proportional. And we're going to use that statement that's up here. When right here, when the ratios between quantities are not constant, the ratio may be linear, but it's not proportional. And so we use this table, make this, squish this a little bit so this all fits together. Now here, I'm going to take this 20 divided by 0 and 24 divided by 2. So we have 20 over 0. That's called undefined. It's not 0. It's undefined. And then I can take the other one, 24 over 2, and that is equal to 12. So this right here, those two rates are different. They're clearly different. So the rate of change is not constant. Oh, no, I'm sorry. The rate of change is constant. That's what makes the straight line. Sorry about that. I want to. I'll take the y value. What y over x is not constant. This is not a proportional relationship. Proportional relationship because the y over x is not the same. Next, let's reflect. Would it be possible to add more points to the graph from x equals 0 to x equals 10? Could we add more? So they're talking about this here. Could we add more points from x equals 0 to x equals? So could we add points on the graph in between these? Would it make sense to? Yes, it would. We could, because this is just 2 tickets, but we can have 1 ticket. 1 ticket would be $22. Be right in between there. We can have 3 tickets. We can buy 3 tickets. We can buy 5 tickets, and so on. So, would it make sense? Yes. Would it be possible? I'm sorry. Yes. We can have an odd number of tickets. Okay. ETS. Wow, that is crazy, but trust me, that says the word tickets. Can I just erase that one? Oh no, I can't. Okay. Anyway, so what we have is another question. Would it make sense? Would it make sense to connect the points with a line? Let's see. Would it make sense to connect this with a line? Well, if we connected this with a line, then that would mean we could have not only 1 ticket or 2 tickets, but a line would connect these, so we can have 1.5 tickets or 1.78 tickets or 2.2 tickets, and that doesn't make sense. So we cannot connect these points and make a straight line. So right over here, would it make sense? I'll say no. It doesn't make sense because we can only have a whole number amount of tickets. And there you go. There you have it. And here we are representing linear relationships using graphs. So I need to introduce this idea of a linear equation. Is an equation whose solutions are ordered pairs, so they're points that form a line when graphed on a coordinate plane, so a straight line. Linear equation, it's an equation that makes a straight line on a graph. The linear equations can be written in the form y equals mx plus b. When b is not equal to 0, the relationship between x and y is non-proportional. So we're looking at an equation, and that is from our earlier equation. What it was y equals 2x plus 20 with the tickets and the amusement park tickets. This is y equals mx plus b, and this is not equal to 0. And if you remember before, that was a non-proportional relationship. Okay, let's move on to this example number 2. I'll move in a little bit bigger here. And so in this example, the diameter of a Douglas fir tree is currently 10 inches. And we are looking at this. So the diameter is that distance across the tree right here, from one edge to the other, going through the middle. Okay, so over the next 50 years, uh, the diameter is expected to increase by average growth rate of 2/5 inch per year. So here's our equation. Okay, we're looking for that equation right there, and we're going to draw a graph of this equation and describe the relationship. So we're going to make a table, and we're going to choose values for x that are easy to work with. So we're going to do multiples of 10, and I'll show you why that works in just a moment. So let's move over here, and I'm going to show you this right here. I'm going to write this equation over here, and I'm going to plug in these values for x. So y equals 2/5 times, and so I will plug in 0, and then I add 10 to that. And so 2/5 times 0, that's easy. That's just 0 plus 10, which is 10. And that's where they got this 10 from, right over there. Now I'm going to plug in 10 for x. And y equals 2/5 times 10 plus 10. So this would be, what, make sure 2 times 10 is what, 20 over 5 plus 10. And they did this so we can have whole numbers right here. That would be what, 4 plus 10, which is 14. And that's where we get the 14 right here. See, now plug in 20, and maybe that'll be the last one I do here for you. So I'll plug in 20. So y equals 2/5 times 20, and then plus 10. So that would be, what, 40 over 5 plus 10, which is 8 plus 10, which is 18. See, that's how they got 18 for, oops, okay, I just did that bad. So, hello. So that's how they got the 18 that is right over here, right there. Okay, now let's bring this over, and let's save this part here. Let's bring that over. Okay, now what we got is these. Now we're going to plot these ordered pairs. So as we plot them, we plot 0, 10. That's this point right here. 10, 14. 1014, 2018, 2018, 30 and 22, 30 and 22, and then the last one, well, that's 50 and 30. And there we go. So it makes a straight line right there, not going through the origin, so it's not going to be proportional. And that is what we got. Pretty simple. Okay, so you try this one. So you make a table of the solutions of the graph. What? Y equals negative 2x plus 1. So your job is to plug these values in for x and get y values, and then plot your ordered pairs on the graph. And so let's see. What we would have is, I'll do this in blue. So we have y equals, that's negative 2 times x, but x is negative 1. Plus 1. See what I did is I have this right here, y equals negative 2, so y equals negative 2, and then instead of x, instead of negative 2 times x, I'm placing negative 1 in place of there. And then I'm going to do a little bit of math here. Negative 2 times negative 1 is 2, plus 1, that would be 3, so this is 3. And then I do the next one. Y equals negative 2 times x, but x in this case is going to be 0. That's the next one, and then plus 1. And negative 2 times 0 is 0 plus 1. That equals 1, so this can be 1. And then y equals negative 2 times 1 plus 1. And that's negative 2 plus 1. Negative 2 plus 1 is negative 1. So that could be negative 1. And then y equals negative 2 times 2 plus 1. And that's what, negative 4 plus 1, which is negative 3. boom. And we graph each of these points. So -1, -3. Notice I'm gonna -1, -1, 3. I'm gonna plot this one, then this one, then this one, then this one. What? -1, 3. -1, 3 is right here. And then 0, 1 is right here. And 1, -1, 1, -1. See, it's looking like a straight line right there. And that's exactly what if it's not a straight line, I know I did something wrong. And then I have 2, -3. 2, -3 is right here. And there's my straight line. And I'm going to work to make that straight line just like that. Look at that perfectly straight line. Anyway, something like that. That's it. So thanks for watching this lesson about non-proportional linear relationships.